Okay, today's going to come first, our last lesson on P1, our first section, and we want to be able to work with some algebraic expressions. And as we work with these algebraic expressions, our goal is to simplify. And sometimes the directions for what simplify means can be a little bit obscure. But we're going to really perform the required operation in these. And right now, the operation is addition. And if you remember, what we do with addition pieces like this is we combine like terms. And the definition of like terms are terms that are the same except for maybe the coefficient out front. So 3x squared pairs with 5x squared, and 2x pairs with negative 10x, and negative 5 pairs with negative 9. So we all remember like terms, correct? So if I have 3x squared plus 5x squared, I get how many x squareds? 8x squared. I can see that we don't change anything with the exponents. Simply add the coefficients. And then 2x and negative 10x, negative 8x, negative 5 and negative 9, negative 14. Now, let's pause. The operation was to add, so we did. Some people will then say, well, can't you take out a 2? The directions don't say to factor. They say to simplify. And factoring is not necessarily any simpler. Factoring is just a different way of rewriting it. So this is fine. You don't have to then factor in the end. Does that make sense? What's different about problem B? The symbol here is multiplication. When you are multiplying polynomials, you have to multiply each part by each part. So I'll first multiply the 4x through. 4x times 2x. 8x, and when you're multiplying, you add the exponents. Since the exponents are 1 and 1, I get x squared. 4x times 7, 28x. Now I'll go to the negative 2, negative 4x, and negative 2 and 7 will make negative 14. Now, part of the simplifying process is that after we perform the indicated operation, if there's an opportunity to combine any like terms, we should do that. Are there terms you can now combine? The 28x and the negative 4x. So I have 8x squared plus 24x minus 14. And just like before, yes, you could take out a 2, but that doesn't necessarily make it any more simplified. In fact, you could factor it right back to where it started from. But we want to just perform the indicated operation. Okay. All right, C looks a little bit more difficult. What's different about C? What's our operation? Multiplication and subtraction. So you see we're going to distribute a positive 3, and I'm not going to distribute 4. I'm going to distribute negative 4. Okay. So anytime you see a subtraction sign outside parentheses, distribute that through. So I have 3 times negative 2x squared gives me negative 6x squared. 3 times positive x, and 3 times negative 3, negative 9. So that's my first polynomial. I'm now going to distribute my negative 4. Negative 4 times 4x squared, 16x squared. Careful here, a negative 4 times 8, negative 5x. And negative 4 times 1, 4. So I performed the first operation, but now I need to combine any like terms. And some people like to draw lines underneath ones that match up. In this situation, I would have a negative 22x squared. Sometimes people cross them off. The 3x and the 20x is going to make 23x. And the negative 9 and the negative 4, negative 13. Now, back in Algebra 1, you spent a full day on addition. You spent a full day on subtraction. You spent a full day on combining together. Then you spent a full day on multiplying binomials where there was no coefficients. And you spent a full day on putting coefficients. You know what I mean? We're doing everything in one day. So if there's something that you find confusing, that's normal, and we can talk about it later. But I'm just trying to put a lot of these together to just get a basic review. Okay, how about D? What's the operation for D? Multiplication, right? I'm supposed to multiply those through. And when I multiply, what do I do the exponents? Add. And the coefficients, you'll just multiply them. So the coefficient in front of x to the third is just 1. So 1x to the third times 2x will be 2, and then I add the exponents to get 4. If you don't see an exponent, then the exponent is 1. Minus 3 times x to the 7th. Can I combine 2x to the 4th minus 3x to the 7th and get negative 1x to the 3rd? No. No, that's voodoo math now. We don't do voodoo math, okay? You can make everything up all you want, and that just doesn't work out. Okay, E. I would be tempted to write this as, I'm going to square that to get 9x squared, and negative 4 squared is 16. Can I do that? No. What does it mean to square something? You take that something and multiply it by itself. So every time you see this squared, you're going to want to write it as 3x minus 4 times 3x minus 4. Right? So now it changes things, doesn't it? So exactly. We're going to FOIL all the way through. 3x times 3x is 9x squared. Minus 12x. Another minus 12x. Whenever you square something, the two middles should be the same things. And then negative 4 times negative 4 is positive 16. So 9x squared minus 24x plus 16. For some of you, I can see that this is really review, and this is easier. Others, it might be, I'm trying to remember a little bit better. Just to give you an idea, I would say that more than 50% of my first semester, this was a more of a struggle to get through. Okay, so I would say that if you're struggling with this, that's okay, and we can get through it. A lot of people did first semester, but if you're finding this easy, you're probably in really good shape moving forward in this class. Trust me, we'll get to harder material. Just want to see some review. And try to see if you can do F on your own, okay? Okay, you should get negative 10x to the 5th minus 6x to the 4th plus 2x to the 3rd. Everybody good? Okay, so we kind of dealt with multiplying, we dealt with subtraction, we dealt with addition. Now let's do with division. And we're not going to divide polynomials, but we will divide monomials. Okay, we will also work with some multiplication again as well in powers. A to the 5th over a to the 8th. Well, looks like I didn't do the letters correctly here. Oh well, I got another D problem. But then b to the 13th over b to the 7th. If I have the same bases, do you know what I do the exponents when I divide? I can cancel them. What is the operation I do? Subtraction. And so we do 5 minus 8, or rather 8 minus 5 is what? 3. Notice, this is very important. Are there more on the top or more on the bottom? So therefore, I will have a to the 3rd, and it will stay on the bottom. The other way to think of it is if you did 5 minus 8, you get a negative 3. And negative exponents must move to the denominator. See that? So b to the 13th over b to the 7th will give you b to the, and there are more in the numerator, so it stays in the numerator. That's a mono, or that's two monomials divided by each other. My operation here is to multiply two monomials. So when I was dividing, I subtracted. When I multiply, I add. Now just remember your coefficients. This is a coefficient of 4. This is a coefficient of 1. So we'll first do 1 times 4 is 4. Then I'll list the x and the y, and we'll start to add our exponents. It will be x to the 4th and y to the good. F, I have two things together. I have division, and I also have a power. You could either do the division first, then the power, or the power first, then the division. I'm going to choose to do the power right away. When you take a power to a power, what do you do to the exponents? Multiply. So you have x to the 6th, y to the 6th, over x to the 6th, y to the 8th. What do I do with that 2? You do whatever you're told. When you see a coefficient, you do whatever you're told. You take 2 and you square it to get 4. What happens to the x to the 6? Because anything divided by itself is 1, right? If it was 0, then the whole thing would be 0, right? But we get 1, okay? It teaches something you guys have never seen before. Subtract, you get x to what power? But anything divided by itself is 1. That's why anything to the 0 power is equal to 1. You maybe always wonder why that was true. Why is it when you take something to 0 power, you get 1? It's because of that. Okay? So, hopefully that makes sense. All right. Y to the 6th over y to the 8th. What's that going to give me? On the bottom. So we have 1 over 4y squared is our answer. The x's are gone. The 4 stays on the bottom. And you have more y's on the bottom than you do before. Okay? All right. What am I supposed to do with the 4? Should I multiply it by 3 or should I cube it? You cube it. With your coefficient, you do whatever you're told. 4 cubed, 64. What do I do to the exponents? I multiply. So I got x to the 18th and y to the 24th. Good. Okay, h is a little bit different. You can see these all are a little bit different. I'm throwing a lot of different problems at us at once. What do I do first? Do I do the multiplication or should I do the power? Here I have to do the power first, okay? The order of operation does come into play here. It's saying to cube this beforehand. If it was cubing everything, that would be different, but it's not cubing everything. So I'm just going to go ahead and deal with this guy first. So we'll write x, y to the negative 1, and then x squared y to the 4th to the 3rd will give me x to the 6th and y to the 12th because I multiplied the exponents. So my operation was powers. Now it's my operation. What am I doing with these two things? Multiply. When you're multiplying, what do you do to the exponents? You add. And negative 1 plus 12 is 11. So this is my final answer. That's it. So I told you you get a decent amount of time to work today. I've got a worksheet for you. I don't think the book does an adequate review of some of the algebra, but tomorrow we'll start into our solving equations, and that'll take us about 3-4 days to get through, and then we'll test probably next week Friday. So I'll give you your worksheet, and that's it.